Hey, Wagwan, it's Mr. Garfield here, and we're going to be looking at a May-June 2017 question, all right? And we're focusing on section 9, which is vectors and matrices, all right? So here we have a vectors question, and it says that the position vectors of the points P and Q relative to an origin O are the vector OP, which is 4, 3, and the vector OQ, which is 5, 0, respectively. The diagram below shows that the vector PR is 3 times the vector OP, and the vector QS is equal to 3 times the vector OQ. All right, so here we have our diagram below. Now, please ensure to put in those lines, all right, those red lines on your diagram, okay, that was not given to us in the question, but I drew it so that you would get the visual understanding, all right, because we're going to need that later on. So the first part of the question says we're to express in a column matrix form the vector OS, PQ, and RS. And part 2 says we're to state two geometrical relationships between the vector PQ and the vector RS. All right, so let's do the first part of the question here. All right, we're trying to find the vector OS. So let us now write part 1 solution. Okay, and I want to move from O to S. So my starting point is O, my ending point is S. All right, so if I'm starting at O and ending at S, I can move from O to Q. All right, I can move from O to Q, and then I can move from Q to S, right? I hope you can see that from the diagram. All right, I want to start at O and end at S. Okay, good. Now, if you realize in the question, it gave us the vector OQ as 5, 0. All right, 5, 0. But we don't know what is QS. All right, we don't know what is QS. But if you remember previously in the question, they had stated that the vector QS is 3 multiplied by the vector OQ. All right, so with that information, I can write 3 times the vector OQ, which is 5, 0. Okay, so now I have 5, 0 plus, I'm now going to perform scalar multiplication here. So it's going to be 3 times 5, which is 15, and 3 times 0, which is 0. Right? If you have a number outside of the brackets, we use that multiply by each element inside. Okay, good. So now I want to add these vectors. All right, let's go back up here. I want to now add those two vectors. Okay, so if I'm adding the vectors, I'm adding the corresponding elements. So it's going to give me 5 plus 15, that's 20, and 0 plus 0, that's 0. All right, and that is the vector OS. Okay, so we're now finished here with the vector OS. All right, now I want to find the vector PQ. I want to start at P and end at Q. All right, I want to start at P here and end at Q. All right, I drew the line and the arrow for you as well. So I could move from P to O and then O to Q. Okay, so let me write a note here. I could write the vector PQ as the vector PO, and then I can move from O to Q. All right. Now you should know that the vector PO can also be written as the negative of the vector OP, right? Those are what we call opposite vectors. So if I know that, then I could also write the vector PQ as the vector OQ, all right? And I'm going to replace the vector PO as negative OP, all right? So you should know those things. Now, it doesn't matter which one you use because both of them will still give you the same answer, all right? It all depends on which one that you're comfortable using the most. So I'm going to write the vector PQ as the vector OQ minus the vector OP. Okay. So we know from the question that the vector OQ is 5, 0. All right, they gave that to us. And they also gave us the vector OP as 4, 3. All right, so I'm not going to subtract these two vectors. When I'm subtracting vectors, I subtract the corresponding elements. So it's 5 minus 4, all right, which is 1, and 0 minus 3, which will give me a negative 3. Okay, and that is the vector PQ. Okay, so we're now finished here with the vector PQ. Let's write that here. Finish with the vector PQ. And now we want to try and find the vector RS. Now let's look at the diagram. We want to move from R to S, right? Starting at R, ending at S. So one way I could do that is write that the vector RS is, I could write the vector RS as the vector RO, right? I'm moving from R to O, and then I can move from O to S, all right? But we also know that the vector RO is equal to the negative of the vector OR, right? The vector RO and the vector OR are opposite vectors. So I could also write the vector RS as the vector OS, and I can replace the vector RO as the negative of the vector OR. Okay? So you should know that. Let's write that down here. All right? So we're going to say that the vector RS, all right, the vector RS is going to be equal to the vector OS minus the vector OR. Okay? Minus the vector OR. Now we already know what is the vector OS. We have calculated that already. All right? But what is the vector OR? That is the question. All right? So what I'm going to do is to just fill in the information that we know, all right, in the diagram here. So we know that the vector OP is 4, 3. They gave that to us. All right. We know the vector OQ, which is 5, 0. All right. They also gave that to us here. Okay. Now, what would be the vector QS? All right. What would be the vector QS here? What would that be? Well, if you remember from the question, it told us that the vector QS is 3 multiplied by the vector OQ. All right, 3 multiplied by the vector OQ, which we know is 5, 0. All right, and if I multiply the 3 by each element inside the brackets, I will get 15, 0. Okay, so I can come down here in the diagram now and write the vector QS as 15, 0. All right. It also told us that the vector PR, okay, if I want to move from P to R here, it told us that that is equal to 3 multiplied by the vector OP. All right, so 3 multiplied by the vector OP, which is 4, 3. And if I perform this scalar multiplication, multiply the 3 by each element inside the brackets, I will get 12, 9, right? So I can now come down here in my diagram and write the vector PR as 12, 9. Okay. Now remember, we're trying to find the vector RS. All right. And we had stated that we need to find the vector OR in order to find the vector RS. Well, if we look at the diagram, we know that the vector OP is 4, 3, and we know that the vector PR is 12, 9. So if I want to move from O to R, it means that it is equal to the vector OP plus the vector PR, right? I hope you can see that from the diagram. I want to move from O to R, so that's O to P, then from P to R, all right? So let's just write a statement here. So this is now going to be equal to the vector OS minus the vector OR, which we're saying is equal to the vector OP plus the vector PR. All right, that's what we're saying. So I'm now going to distribute the negative sign inside the brackets, which means that each term inside the bracket will be affected. So I'm now going to write the vector OS minus the vector OP minus the vector PR. All right, that is what I would get when I distribute the negative inside. Good. So this is now equal to the vector OS minus the vector OP minus the vector PR, right? But we already know what is the vector OS. We had calculated that to be 20, 0, minus the vector OP, which they gave us as 4, 3, all right, minus the vector PR, which we had calculated above to be 12, 9. All right, that is what we have here. Good. So now I am subtracting 3 vectors, right? I am subtracting 3 vectors. Good. So what would that be? What would that be equal to? So if I'm subtracting the vectors, remember that I'm subtracting the corresponding elements, all right? So I'm now going to have 20, all right, 20 minus 4 minus 12, which will give me 4, and then 0 minus 3 minus 9, which will give me a negative 12, okay? And that is the vector RS. Okay, that is my answer. All right, so we're now finished with the vector RS, and hence we are finished with the first part of the question. Okay, now we're going to answer the second part of the question, which states that we are to state 2 geometrical relationships between the vector PQ and the vector RS. All right, let's just write down what we know here. All right, let's just write down some stuff here. So this is part 2 solution now. All right, they ask us to state 2 geometrical relationships between the vector PQ and the vector RS. The vector PQ we know is 1, negative 3. All right, 1, negative 3, which I had calculated previously. And we know that the vector RS, which I just calculated, is 4, negative 12. All right, now what is the relationships between these 2 vectors? Well, if you observe the vector RS carefully, all right, if you observe the vector RS carefully, I could write it as 3, I could write it as 4, sorry, 4, all right, and then multiplied by 1, negative 3. Why could I do that? Well, because if you notice, 4 is a common factor of both of the terms in the brackets here. 4 is a common factor for both of the elements inside the brackets. All right, so if I could factor out a 4, I will get 1, negative 3 remaining. All right, if you should perform the scalar multiplication again, you could see that it will still give us back the 4, negative 12, right? Because 4 times 1 is 4, and 4 times a negative 3 is a negative 12. Okay, good. So now we're saying that the vector RS is 4 times 1, negative 3. Now, what do you notice here? Well, we have the vector 1, negative 3 here, right? And we also have the vector 1, negative 3 here. Okay? So we are saying that the vector RS is equal to 4 times the vector 1, negative 3, which we know is the vector PQ, right? So what we're saying is that 1 is a scalar multiple of the other, okay? 4 is the scalar that we're talking about. So if that is the case, then it means that the vector PQ and the vector RS are parallel vectors, okay? And this is the reason, because the vector Rs is equal to 4 times the vector PQ, right? If we're saying that vectors are parallel, it means that one can be written as the scalar multiple of the other. Okay? Good. So let's just write a statement here now. All right, let's write a statement here and say that the vector PQ and the vector RS are parallel. All right, they are parallel since the vector RS is equal to 4 times the vector PQ. All right, so that is one geometrical relationship. All right, that's one geometrical relationship. Okay, good. So let us just come back to the diagram here and fill in one more thing. All right, we're going to fill in one more thing here. So we know that the vector Rs is 4, -12, right? We just calculated that. Good. And we are focusing on the vector PQ, which we know is 1, -3. And we're focusing on the vector Rs, which is 4, -12, right? So clearly from the diagram, you can see that they are parallel vectors, right? They're running in the same direction, and we know that we can write the vector Rs as what? 4 times the vector PQ, right? So we know that they are parallel. But remember it said that we're to state two geometrical relationships. Saying that they're parallel vectors is just one of them. But what else do we notice? All right, this probably might be a tricky one to notice, but we can look at it in terms of their magnitude, right, or their length, okay? We're going to be looking at the length of the vectors. Now remember that in order to calculate length of vectors, it is going to be what? The square root, all right, of x squared plus y squared, right? You should remember that. That is how we find the length of vectors. And that is really coming from the Pythagorean theorem, all right? So let's find the vector Rs, the magnitude of the vector Rs, all right? So the magnitude, we normally denote it like this, or some persons may write a double stroke like that, all right? So this is equal to the square root of x squared plus y squared, all right? We know that. Now what is x? X is 4, right? Remember we're writing it in the form of xy, remember that? Okay, so x in this case will be 4, so that's 4 squared, let's write that, 4 squared, plus y would be -12, right? That's -12, and we're squaring that as well, all right? Now, 4 squared is 16, all right? And 12 squared is 144. So that's 144 plus 16, all right? 144 plus 16. So you could write it like that, or we know that we can write the vector Rs as what? We can write it as 4 times the vector PQ, right? 4 times the vector PQ, which is 1, -3. So you can either work with the 4, -12, or the 4 times 1, -3. All right? So I'm going to work with the 4 times the 1, -3. All right, just to make it a bit more easier for you. So we're saying that this is going to be 4 multiplied by the vector Rs, 4 multiplied by the square root, sorry. All right, 4 multiplied by the square root of x, which we can say is 1, all right, plus y squared, which you can say is -3 squared, right? Now 1 squared is 1, and -3 squared is 9, okay? So what we have is 1 plus 9 here under the square root, and we know that is equal to 10, right? This is going to give 4 square root of 10. All right, that is the magnitude or the length of the vector Rs. Good. So we're saying that the vector Rs, the length of the vector Rs is 4 root 10. Let's write that here. The magnitude of the vector Rs is equal to 4 root 10. All right. Now, what about the length of the vector PQ? Right? We know that the vector PQ here, let's go back to it. The vector PQ is 1, negative 3. So what can we say about the length of that? So we want to find the length or the magnitude of the vector PQ, right? That's going to be the square root of x squared plus y squared. X in this case is 1, right? 1 squared plus negative 3 squared, right? So this will give 1 squared is 1 and negative 3 squared is 9. So what we have under the root is 1 plus 9, which we know is 10, right? So this is equal to the square root of 10. Good. So what can you notice here now? What do you notice here? Let's look at it. We have the square root of 10 here, and we have the square root of 10 here, right? So we can also say that the vector Rs, the magnitude of the vector Rs, so the magnitude of the vector Rs is equal to 4 times the square root of 10, and we know that the square root of 10 is the same as the magnitude of the vector PQ. All right? So we could write that as well. So this is one geometrical relationship. All right? That is one geometrical relationship. And this is another geometrical relationship. Okay? And that would be the end of this question for vectors. All right? I hope it was helpful. If it was, please ensure to like up this video. All right? Share it with your friends. And if you aren't already a subscriber, please ensure to subscribe to the channel. All right? And please, if you're not clear on something, don't be afraid to ask questions. All right? If you have any questions, you can put that in the comment section below. Okay? I am Mr. Garth Reed, student ambassador for the University of Technology Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.